This is more. We've been through it in previous talks, but given that we'll be getting fairly deep into streams, this is very important to sort of get the basics. So, in the old world, we have anonymous classes. You've probably all seen this at uni. Probably never use it afterwards. If you're still writing GUI code, you're still going to have event handlers. And one thing you'll notice is a majority of this is just the same. There's nothing in here except for this single line that actually is your code. The rest of it is just boilerplate. And it's what everyone complains about Java having. And so one thing that Lambda really takes care of is getting rid of some of that boilerplate in these situations. So we'll see how it does that now. So we've now moved our 5 or so lines in that event handler to something much simpler. And in doing so, we've eliminated all this boilerplate, and we've really made it all about what we're actually doing. And this is the core of the Lambda syntax. We've replaced this anonymous class with an object, a little syntactic sugar, and what we're actually doing. And now how does that work? That works because of functional interfaces. There's a new annotation in the Java JDK. So I'm going to use an example here to demonstrate one of the ones that we've already got, and that is predicate, which I believe probably existed in some form, but has now been moved into a different package. And so the only rule with functional interface is that your interface has a single method that's abstract. And that's because it needs to know what your Lambda is actually going to do. So we'll see the predicate here as test. And it's T, so you don't have to worry about types, it's all taken care of, and it returns a Boolean. It can, however, have another new feature with default methods. So you might have recalled that in the past, when you're extending interfaces, you need to implement everything, which can be a bit of a pain, especially when you just end up throwing an unsupported operation exception and don't really help out anyone anyway. And so what they've introduced is default methods, which can be used. Now, I was actually hoping you could use these as lambdas, but unless someone knows better than me, you really need to take the object itself as a predicate, and then you can use negate and all that. You can't seem to use it with the lambda syntax. I'll explain that in a bit more detail later on. Okay, so just to demonstrate how these work, because I had a bit of difficulty writing these slides because a lot of the cool stuff you can do with them involves streams. Given Con's talking about streams, I had to shy away from using streams. So I've made a static method called filter, and it accepts a list and a predicate. It's pretty obvious what it does. It iterates through the list and adds things if they match the predicate. This is sort of the simplest example of a filter function. And what I'd like to show you is how you can use that with lambdas to really write much shorter code, and in my opinion, much nicer code. So this is how you would have done it previously. With an anonymous class, new predicate. In this case, I want all the odds. So I'm overriding the test method. And again, we come across this point where that's really all my code. The rest is just boilerplate. The rest is stuff that I'm not really interested in, and it's just kind of confusing to watch. And it means I have to type more. So what we've replaced that entire 5 lines with is this. So this is the predicate at its simplest. So we have, again, we have the variable, the syntactic sugar, which is an arrow, and then the lambda function itself. So it's the same logic as before. We're filtering out all of the odds. And now instead of having to extend that anonymous, build that anonymous in a class, we can just put exactly what we want there. Now, one thing to note is this is obviously a very simple example with just a single line. You can also put braces there and have multiple lines if you want. But yeah, this is the simplest example. And at the end, we print out the size just to show that it's still working the exact same way. So the other important thing that has come in with this is we need to reuse existing methods that are already there. So we have method references. This looks fairly familiar if you're used to other functional languages. Certainly you can't. I think another one uses similar syntax, but you've got a fair bit of choice. So you can refer to static methods by using the class name, the columns, print. Instant methods if you have the actual instance. And the same again, if you've got your object, you can also just refer to page, get content. And finally, and this will be demonstrated better in the stream store, you can use your constructor as well if you want to pass in a constructor. So how can we use these? Again, without streams, it's difficult. So we go back to our filter function. Say we want to actually see what came out of that. This is the old way you do it. So, well, when I say old way, Java 5 way, I guess. So we do have a nice iterative syntax. Again, though, we're just printing out that. And really, a lot of that is unnecessary. If you've seen JavaScript, they've already got this. They've had this for ages, and you really want to. You don't want to have to type that syntax every time. So we have a new, more powerful way to do that. And that's like this. So again, if you've used any modern JavaScript library, I don't think it's actually in JavaScript, you've probably seen this. You pass it an anonymous function in JavaScript, and here we can pass it a method reference. So we're taking system.out, and we're passing it into the printline function. And the outcome of that is exactly the same as our previous source code. So, we've just taken an 8-line method and compacted it down to 2 lines that explicitly state what you're doing. There's a lot less boilerplate, there's a lot less typing, and for whoever needs to look over your code, just a lot less to look at. So just as another quick example of this is just to show how you can use it without using the built-in things. So in this case, I wanted to surround my numbers with types. So I made a static method in my class test, and I can refer to it like that. So these are just a few of the things that you can do with these methods. As I said, it was a brief overview, and hopefully you understand the syntax. Hopefully you've looked at it in the past. Hopefully you're playing with it now, because it is a bit to get used to. It's very different to traditional Java, but as you can see, it does really tear down a lot of that boilerplate that people have complained about in the past. So that's about it from me. All of the functional interfaces are in the same package. I believe it's java.functional. So, Java utility function. Yeah. So Java.utility contains all the pre-built functional interfaces that you can look at. Again, I've only touched on predicate because it was pretty much the easiest one to exploit here. But when you're dealing with streams, you have a lot more options. You can do a lot more interesting things, and you can really, you'll really be able to see how this trivial example, which is just printing some odd numbers from a list, combined with some more of the added functionality, can really transform the way you write your code and the way you're going to see code in the future, hopefully. So, does anyone have any more questions before we move on to streams?
Yeah.
No, you go. You're using, I think you need to use objects. I didn't try it myself.
So, yeah, I don't have enough time to touch on it, but there's a concept of an int string and a double stream and a long stream. So specifically to work around that very problem. And
it doesn't box it into object?
It tries not to. So it tries to keep it in primitives for performance reasons, and then you can opt to, if you're taking something that takes a capital integer, for example, then you can opt to box that around. So I'll show a bit of that.
You mentioned that operator, the syntactic sugar, little
the arrow.
Does that? It looks sort of like the threading macro in Clojure. Does it operate the same way? Which is where you'd say I is passed to this next function, which is passed to the next function.
I haven't used Clojure.
It stops you nesting a whole bunch of things.
How does it do that? Sorry.
Well, are you passing in a method, like a function reference to another function? So
yeah, well, if you have there, you've got I is passed to I%2. What's that actually saying?
Yeah, I mod 2.
I mod 2.
Yeah.
Okay, so you couldn't then pass that to I trunk or I trunk something.
Yeah.
Yeah. Well, you can. I have seen some mailing list examples where someone's being funny and like generating a stream as a result of a stream and passing a function itself around. But yeah, as it stands there, the idea. I think maybe what might be closer to referring to is the test.testprint is where you've got to actually, that's referring to a function. That is being.
So where you do that in Clojure, you'd say you have one function that passes its output to the input to the next.
So you're referring explicitly to a function, not defining it. So in this case, you're defining the function as, and this is a predicate, so it just needs to be something that returns Boolean. So you're defining it as I mod 2 doesn't equal 0.
Yeah, but you could. So I imagine define that elsewhere.
Yeah.
Just call a reference to it.
Yeah. So I could make that return Boolean, I think, and then pass that through there.
Yeah. Probably worth noting too that the type inference in Java 8's gotten a lot better. So the fact that you're doing I mod 2, I don't know if this is 100% correct, but the idea being that if I mod 2, it knows it's an integer, the compiler will pick that up, so it knows
it's one really nice. So the full syntax, you can actually specify, so integer I, but it's smart enough now to infer that from the circumstance you're in. And IntelliJ is good enough to give you full code completion on that I. So it knows exactly what type it is. And you can use any of the integer methods. And more importantly, if your list wasn't just a list of integers, you could use whatever here belonged to that object. Filter was that function I defined earlier. So yeah, we do have streams which pretty much do what this does. I'm sure you'll discover those soon. Yeah. Yeah. Mm-hmm. If you have, yeah.
Yeah, let's leave that one for the streams.
Streams will take care of that more, but and probably I should have gone into it in this talk. So this is completely type safe. So if I had a list of employees, to use the standard example, I could do something on employee name, for example, and I have full access to it there.
Before it's sent to the JVM, is it bytecode generated behind the scenes?
Yeah.
When you compile?
Yeah.
How
So
does the debugger? How does it look in the debugger?
debugger.
Terrible. No, it's
The debugger will, like, it's smart enough to know what line that happened in, and it will tell you that it's happening in a Lambda. If you look at the stack trace, it's a little less clean. Like, you will see, can't remember if it was for this example, but you will see a bit of sort of extraneous stuff in the stack trace. Like, there will be several calls to internal things. But it's not so bad that you will be confused about where the error is. It will still tell you that the error happened on this line. Obviously, there's a lot more happening on that line now, so there's a little bit more to work through. But the debugger still takes care of it, and you can still step through it as if it was a normal anonymous class.
given that you're sitting next to Mandrew, I don't want to point you out here, but what's the Eclipse's story for debugging?
I'm not much familiar with how that works, but Lambda is, if you compile Java which involves Lambda, then you can, I've inspected the code and then I can see the variable, the value at runtime and things like that. So kind of works smoothly is what I feel, but then as developers really happy.
So, I mean, initially there wasn't debugging symbols generated properly, so in the early the Lambda stuff, and that was pretty reasonable later on in their list, and then eventually they put it in, and then all the other IPs started picking up on that, so now you can debug through just the same way you do. Sure. Right. But yeah, so it's in there now, and we've got support, so it's not.
And it's yeah, I can only speak for IntelliJ, which I've used to debug this kind of stuff, but I assume they're generally built on the same principle. So I think Eclipse probably has similar support, and you'll pretty much have the same debugging capabilities as you had without using it.
The I%2,
Yep.
Is there a dot int value bracket inferred somewhere? I mean, I didn't think you could go capital integer dot over the %2. Where's the dot int value happening?
I think it gets boxed because I'm using it with the two. So I think
Is that specific to Lambda?
No, I think
Or is it
that's just Java in general. In fact, I used it back when we had an anonymous class. Yeah, so I think because it's against the two, it will just box to a.
It'll have its own dot
Yeah.
int value.
Can I get you to just go to the slide on functional interface, or something that's got functional interface?
Do you want a description?
Yeah, so just Daniel did mention that like there is this app functional interface, which basically just means it's a interface with one method that you can implement and then a whole bunch of other default methods. It's just a marker interface so that IDEs can pick up on that, but the actual Java language doesn't care, so you can replace any
Anytime you see an instance like this where there's one abstract method, I believe.
Yeah.
Yep. And if you try and apply a functional interface annotation to a class that has multiple, it will complain to you. So it requires this kind of setup. One example that straight off the top of my head is runnable. You can use lambdas if it's runnable straight away if you've just got a single line that you want to push off into another thread.
The neat thing that comes out of this is that you don't actually, you're not as much bound to types anymore. I haven't explored this myself, but last month when Peter Laurie was here, he was telling me that the fact that like I could have another class, another interface that had the same method signature as test and pass it in. Let's just pretend the gate wasn't there, but it was just one method with a test that takes a T. And then if I had another interface with the same method signature in it, I could interchange those. Like when I'm using that and I'm declaring a lambda inside a method call, then it can be whatever it wants. It'll just fit. So like I'm creating a new predicate, and in theory, it to be possible to pass in whatever, so it doesn't have to actually be the same type. It's something I want to explore further. It's a bit of, I guess, a little bit of more flexible typing.
Yeah, the best way to get used to all of this, because it is, it's a big change to the way, and Oracle are pushing it as the biggest change to Java ever, and using it's the best way to get used to how it works and how the syntax all fits together. Especially if you come from a traditional Java background without using functional language as much, it's a bit to understand, it's a bit to get used to. Obviously, if you come from something like Scala, it's just a matter of slightly different syntax. Yes. Cool. So we'll move on now to streams, which is the good stuff.